Hey there, welcome back to the channel and let's just get started. So in previous videos, like many videos, I've made some mistakes and today we will be correcting them. What kind of mistakes? I'll show you. And I've left notes like where do I have to do some changes. It's on 179 something. Yeah. Okay. Yeah. So first, let's go ahead and look at like how our code works. Because I think we have to look at we do like we do need to look at like how code is working. So this is my void pointer, uh, free pointer. So we have a free list. Free list is basically a linked list that has free blocks inside it. So let's say a process comes to us and asks for 500 bytes of memory. Well, we have to give it some space. Either we can call SBRK, or we can allocate it from some of the free memory that is already present with us. So that's what uh, free pointer is about. So let's go ahead. Okay, so I'm currently working on the malloc function. Uh, the free function is also present down over here, but I will work on that later. So align size. So whatever the user asks for size, let's say user asks for 14 bytes, it will be converted to 16 bytes. We need it aligned to 8 bytes. So then uh, then we call the iterate free list function, which is present above here. We send in the free pointer and we give it the align size, and it will return a void pointer to us, which is the address of the free block that we found. Now, how does the iterate free list work? We create a copy of the free list. Sorry, we create a copy of the free pointer, and then previous block. This is the previous block. So initially, uh, then our copy free pointer will be pointing to the first block. Our previous block definitely should point to null. Why do we have a previous block? I'll explain that because so let's I'll explain it right now. So let's say we found the appropriate block that we want, and it was the first block itself. Now the free pointer should not point to that block because that is the allocated block. Uh, so we have to point the free pointer to the second block now. So that's what we are using free block for, previous block for. So I'll show you the working. So while copy free pointer is not equal to null, so until the linked list ends, uh, then we have not technically a next block, but helps in saving copy free pointer in a different form, so it's easier to dereference it later on. Yeah, okay. Yeah. This is just for ease. So copy the copy free pointer, next block, size block, we get the size. But you would be asking like how are we getting the size? So any free block has the structure of, as you can see over here, it has a structure of size, the pointer. This pointer will have the address of the next free block. This is space, the actual space, which is the value present inside this size value, space, and size again. There are two sizes. This is the header size and footer size. Why do we have two size values? It's for coalescing, which will help us later on. I haven't implemented coalescing right now, but wait, let me check. Is it recording? Yeah, it's fine. So, um, yeah. So, how are we getting the size? So, copy pointer will point to this pointer, and then we move size t size behind. Size t size is the number of bytes that the size t has on this architecture. So a pointer points to over here, and then we move size bytes behind, and that's what we get. We are now pointing to the start of the entire block, like the beginning of the entire block, and then we cast it into a size t value, and then hence we get the size of the block. So Actual size is equal to, yeah, dereferencing the thing. And now we will check actual size plus pointer size is greater than or equal to requested size. So why are we doing this? Well, the thing is, this condition is like a bit complicated, so I have to explain a lot of things. I should have added a comment over here, but let me think about it. I don't remember it myself. No, I do have it in my mind, but I just woke up and I can't recall any of the stuff. Wait, actual size plus pointer size is should be greater than requested size. Oh yeah, yeah, I get it, I get it. Yeah, yeah. Sorry. So what it basically means is that so let's say our structure looks like size, pointer size, space, and size. Let me show you a diagram. Yeah, I'll show you a diagram so it will be like easy for you to understand. So let's say let's say we have a free block. This is the size, this is the pointer, this is the actual space. So let's say it has the value of 100. This is actually 100 bytes. And then we have size again. So what happens is that, let's say this is the allocated block. Let's say a process comes to us which is asking for 98 bytes. Well, we can definitely allocate this block, right? We have 100 bytes of free space and we can allocate 98 bytes very easily. What if a process comes in with exactly 100 bytes request? We can still do it. But what if a process of 104 bytes comes to us? Should we allocate this block to them? Well, the thing is that we should. And why is that? Because in allocated, let's say this is an allocated block now, what will the block look like? The block will look like this. It will have the size value and it will have another size value, which is the footer one. But as you can see, we don't need the free pointer like we don't need the free pointer, right? Because free pointer is present for us to point at the next free block. But since it is an allocated block, we don't need to point to anything else. So we can just merge, we can just eat up this space so that our available space increases by 8 bytes on 64-bit systems. Not every time, but that's what we are saying. So, so if a process comes in and asks for 104 bytes, we can definitely allocate this space because we don't need this pointer right now. So max the space that we can allocate is 108. If a process with 110 comes to us, we cannot allocate this block. We have to go to the next block and uh, or like iterate the free list. Now that I think of it, it shouldn't be iterate free list. It should be traverse free list. But that's fine. I will change it up later on. So that's what the if condition is about. So if condition is checking that the actual size. So this is the actual size, which is 100 plus pointer size, which is let's say 8. 108 is greater than or equal to actual size. Sorry, what are we saying? Requested size here. So that's what they are. That's what the if condition checks. If it's more than that, if sorry, you can't see that. So if requested size is more than 108, then we have to traverse the free list again. And if it's smaller than that, we can just allocate this block. So I will also there are a couple of different things too. For example, like let's say a process only asks for 5 bytes. Well, we cannot allocate that entire 100 bytes of block, right? We have to. do some optimization. So that's what the splitting part comes in. It's present in the myalloc function. I'll show you. Let's cover this first. So if you do find the appropriate block, what do we have to do now? So first we have to check if it is the first block, if the appropriate block is the first block, like the very first block itself, then we have to make sure that the free pointer does not point to it, right? Because it's an allocated block. It's done. So if free block is equal to if previous block is equal to none, that shows if previous block is equal to none, that says like the current block, uh, the copy free pointer. So the current block is the very first block. So we'll just make it so there's a bug. See, so I dereferenced, so I changed the value of the free pointer. Previously I did not. So the free pointer is now pointing to the next block. Boom, done. Sorry. So and if okay, why do I have so many things? Okay, skipping the chosen block and making the previous block point to the next block. Okay, so else previous block, we have data. Previous block is a pointer to pointer, right? Previous block, that's a null, and we change. So previous block becomes the copy free pointer. We cast it into the pointer to pointer, and then dereference it to change the value of previous block to the next block. Yeah, that seems correct. So I don't think we have anything over here. I added this HHH so to like look at it, but I guess I changed the things in the previous video itself, so we don't need that anymore. So we changed the previous block. So now let's say we found the appropriate block at block number two. So we have block number one, block number two, block number three. These are all free blocks. If you found the appropriate block to be block number two, so now block one will point to block three. That's what we did over here. So then we return copy fill pointer if it's found to be appropriate size, and if not, then we'll just traverse it. So previous block becomes the copy fill pointer. That copy fill pointer is now pointing to the copy pointer is now the dereference next block. Okay. So return void pointer minus one. That's fine. If you don't find the block in the traverse, either- let's change this. It should be traverse freelist. Traverse freelist. Traverse. Let's save this up. So now man malloc, we come over here. Let's say we do find a block of appropriate size. We get a pointer to it. If freelist is void pointer minus one. So this is the condition where the ideal block was not found. Calling none SBRK for new memory. You can read this. So new block, we call them SBRK. This is a function that calls SBRK itself, but we have to use this one. Align size precisely, size precisely, size. Why do we have this over here? It is because the new block should have enough memory. So like let's say the as I've said, like allocated block doesn't itself like it doesn't have only the space itself. It has size values too, the header and the footer one. Hence, we are asking for some 16 bytes extra space. Sorry, 16 bytes of extra space so that a new block is of the correct size. Set the size value at header and plus one to unit allocated block. That's correct. So new block, so the size, new block. Yeah, so we get the pointer and the initial, we cast it into new block. So that's correct. We dereference it and align size plus one. That's correct. Footer new block is new block. We are currently pointing to the start of the new block. We move it by size t, and then we move it by align size 2. So now our pointer is present at the footer size, the footer size value, and then we cast it into size t, and then we change the value of it to align size plus one. What does plus one denote over here? Plus one denotes that the allocated block is that is not it is the allocated one. So every single free block that is present is a cast is like aligned by 8 bytes. So it is by default like every block will have like even value. Every free block will be of even size, even size value. But if we find that a block is odd, which is plus one, then we can say it's an allocated block. This will help us in the coalescing part, not right now. And then we return void pointer char new block plus size t size. Yeah, we return the pointer to the you can say the actual space, not the new block itself. That's correct. And then header size pointer, size t. Yeah, so this is where we do find the appropriate block, and that's what we are going to do some changes on. So this is now we will also see the splitting part. So size t header size pointer is size t uh, yeah cal pointer. So free list output. So this is where we got the pointer. So we move it behind by pointer size. And should I simultaneously show you guys what I mean in diagram? I think that will be correct. But I have to constantly change it some stuff, right? Okay, let's just continue. So actual block size is equal to yeah. Let's continue. So free list output we move behind by size t. As I've said, uh, where is it? Where is it? Yeah. So this is so our block actually looks like size pointer space size. You guys can't see it, right? So our block actually looks like size pointer space size. So our pointer is currently pointing to this position. We move by pointer size behind. Uh, Now that I think of it, it should be size t size. Yeah, free this output minus. That is correct. Size t size. Even though it's the same thing, but still. So actual block size, not same thing, but okay. Actual block size. So sorry. So actual block size is the then our footer is released outputs. So this is we are pointed over here. We move by pointer size ahead, and then we move by line size ahead, and now we are pointing over here. Pointer size pointer, and the size difference. We haven't done anything. We will change these values soon. So just so we just have the pointers to it. We will change them later on. So the size difference is actual block size minus align size, where actual block size is the value that we found of a block size, but we definitely don't need the entire block, right? As I've said previously, if we have a free block that has 100 bytes and the process only asked for 5 bytes, we shouldn't allocate the entire 100 bytes to it. That is a very bad case of internal fragmentation. So, in order to, uh, you can say, make like reduce internal fragmentation, we are using splitting. So we don't necessarily use the entire block, we split it. So for that, we are getting that like the size difference. What is it? So actual block size minus align size. Size difference will also be a value that will be a multiple of 8. So if size difference is greater than or equal to 24, why is this hard-coded value? Now that I think of it, I should change it. So let's define a value over here. I shouldn't have done that. Let's define it over here. So pointer size over here. Let's define it over here. So let's define. Wait, now that I think of it, my pointer size. I've hard-coded that value as 8. Okay, that is bad, but okay. I guess it's fine because no, it's not fine. Ah, wait. What is the correct way to get like a pointer values for like the system? So let's try. So how to get the you can say pointer size for architecture in C. Size of pointers in C. Yeah, but I want this. Should I make it like yeah, but they don't understand what I'm saying. Yeah, the size of a pointer in C. Scale pointer P. Let us just see for concrete example. Okay. Oh yeah, I can do this. Size of cat pointer. Yeah, that's easy. So pointer size is now cat pointer. Sorry, size of. But would that work? Size of cat pointer two. Let's check would that work. So we go here and then temp.c. Let's make a name. You can see. So temp.c hashtag include stdio int main as a we have to define values, right? So we define pointer size, size of cat pointer, and what else do we have? Then what is it? ZT? Sorry, percentage ZU. This is what I have to use, right? It's a size value, right? And pointer size return 0 client temp.c and to output. Yep, it works. Let's go cal pointer. This should work. Yeah. So now we have what were we doing initially? Yeah, minimum space. Let's call it minimum space. Yeah, that's cool. So our minimum space should be, and we cannot declare it over here, right? We have to declare it somewhere below. Let's declare it over here. I'll check minimum space. That should be all the block split. So hash define minimum space. Minimum space should be. Wait, can I do that? Dot C. Let's say I have and then I'll define size to size, size to size. which is size t. That's what it did, right? Yeah, a line of size t, size of size t. Oh, we have to also align it. That's okay. So I have to move that to, yeah, okay, that's fine. We'll also align this line because we want a multiple of 8. Why though? Not sure, but they did it. That's fine. So minimum space is a line, size of, and then, well, not size of. We'll just, yeah. So minimum space, can I do that? Size of size t. Yep, that's correct. Yep. So now can I define a macro that uses the macro? So minimum space should be equal to size plus size t size plus pointer size minimum space. Would this work? Yep, works. So size t size plus pointer size plus size again. That's good. Hundred equal. Yep, yep. So minimum space. Yeah. So if the size difference is greater than minimum space, so that we can split the block. I'll show you the easier side first, like where we just allocated. So here we'll just change the values. So now, as I've said, we can use the pointer value. So now that we know that we are not going to split the block, and we are just going to use the entire block. So we just have to change the values of the size because we get the extra pointer size value. As I said, we will, our actual our actual space will need the entire pointer to, so that we have 8 bytes more or 4 bytes, whatever. So pointer size plus one, that's what we did over here. And then here, so this is simple if else. So uh, nothing much over here. And we are returning failures output because this is fine for else condition. Right? Okay. So size difference, minimum space, yeah. So block space is equal to actual block size plus pointer size minus align size. So actual block size, so that's what we get from this, plus pointer size, yeah, minus align size. Yeah, yeah, yeah. So block space is the value that is left when we allocate the, you can say, align size. So let's say the total usable space that we have left with, yeah, which is the space plus pointer size. Yeah, that's correct. So the total space that is utilizable is space plus pointer size. And from that, we will be allocating a line size to it, right? So the entire block space that will be left to us is the block space. So now we have to make it so that the block space is now the new free block. So that's what we are doing over here. So void pointer split block, free list output plus pointer size. So free list output plus pointer size plus align size plus size to size. Yeah, that's correct. So split block is now pointing to the, you can say, the beginning of the new block. So it's pointing to the beginning of the new block. Uh, that's fine. You guys will understand that. Um, this is the beginning of the new block. That's fine. So real block space is equal to block space. That's what we get over here. minus size to size minus size to size minus body size. What did we do here? So real blocks. So block space is the entire space that's left after allocating. But even from that space, they still won't be used to this. They still won't be able to like use the entire block space, right? We should have two size values inside it, and we also have a pointer size value inside it. So that's what we are subtracting, and then we get the real block space. This is the real value that is present. So now we have to make it so that the header and footer values have this value inside it. So size t pointer, we cast the initial size because it's in the start of the free block and header is at the start. So that's what we do over here. And then we split block, we move it by size t value, then we move by pointer, and then by real block space, and hence we find a pointer at footer split block. And now we will change the value. So header header split block is equal to real block space, footer split block is equal to real block space. That is fine. So we change the values of them and split block pointer. Wait, what is this? Getting the pointer with the split block. Yeah. I think we're good. So now we have to change now we have to make it so that the new split block is present in the free list, right? Obvious. But we cannot add it to the like we shouldn't add it to the end of the free list. We will be adding it to the start of the free list. So to get that, we need a pointer to the free pointer. So split block, the size t size, we move it by size t size forward, and then so split block, we have to dereference. Why do I forget every single time? We will make it so that the split block, so dereference it, but we cannot dereference a pointer, so we'll say this is a pointer to a pointer. This is a pointer. So we'll say so split block because split block is actually a pointer to a pointer. So consider that the split block is a pointer to a pointer. And now we are going to change it to what? Wait, this shouldn't be like this, right? We are so split block pointer. Wait. So we have over here. Wait. So get div. So these are the changes that we have made. Okay, this is fine. Not much changes. So this is says to this is the previous video, but I forgot to like commit and all. So good. So we have later. Let's see. So now we haven't changed it. Okay, this one. So 100, Okay. So wait. So we get a pointer to it. We have to make it so the split block is now has the values to the next free pointer. So split block. We will say that split block pointer is actually a pointer to a pointer, and it should have the value of void. So free pointer is already pointed to a pointer. What's the what's the problem? It's G, yeah, it's already pointed to a pointer. So it's not. Yeah, we have to cast it. So okay. So we'll say free pointer is a pointer to a pointer, and just a Okay. So we are back. So yeah, overview. Yeah. We will say that the split block is a pointer to a pointer. We change the pointer value to three pointer cast it into point. So three pointer points to the next block, right? Like it's a pointer, but it will point to like the first block. So you can just say like uh, we just want the value of it to be three pointer, right? That seems correct, I guess. And now the free pointer will point to split block pointer. Yeah, this is correct. I will write over here. So making it so that split block points to the start free list, split block becomes the new becomes the first free block in free list. Yeah, I think that is yeah. So I guess this is it. This was kind of like an explanation video. We didn't do a lot of things except like cover some things. So this is the man mallet function that was present earlier. I changed it. So this is our my mallet function. It's working. So now in the next videos, we don't know how many minutes are we in? So I should see this. Okay, status. So how many minutes are we in? 32 minutes. Yeah, yeah. It's a it's kind of this was like an explanation video. We didn't do a lot of things. In the next videos, now now that our my mallet is like complete and it's working, and when it's not working, there will be some bugs. Uh, but yeah, we'll fix it. And in the next videos, in the next videos, not next videos, but in the next video itself, we'll be working on another. We will be working on unit tests. So like since now my mallet is working, so we need some kind of testing for it. So there is a validator, you can say validator header file that has some functions that will help us test with some traced files. So that's what we will be working on. This is what it looks like. Let me show you. So one and yeah. So yeah. So this is what it looks like. Zero page. Where was it? It was using that's what it. So it's using like the trace files. Oh, sorry. No, wait. Okay. Okay. So yes, that is it. So I guess that is it. Uh, Thanks for watching this video. I'm Anita Bacharne, and I'm enjoying it for fun. Bye.